Hi, in this lesson, we'll consider how to find the modulus of a vector. With the aid of these two examples, we'll see how to find the modulus and direction of a vector. Now let's start with the first example. Well, to find the modulus of this vector 1, 3i plus 4j. Let's call this r. Let's label the vector r. Now when considering a vector, remember the unique thing about a vector is that it has both magnitude and direction. Now if I have a vector r, if this is my vector r and this is my y-axis and my x-axis, obviously I have this, let's tag this place as 3, then on my y-axis I have this as what? As 4. So picking my vector, I have my vector this way, I have vector r this way, so that vector r makes an angle theta with the x-axis, so that my r here becomes the modulus of this vector, also known as the magnitude of this vector, and theta will be the direction of this vector. Now using our Pythagoras theorem, if this point is 4, obviously from here to here I have it as 4, and from here to this side I have it as what? As 3. This is a right-angled triangle. And using my Pythagoras theorem, we can easily say that my modulus r is the same thing as the square root of 4 squared plus 3 squared. Remember, for our Pythagoras theorem, it says that our c squared is equals to square root of a squared plus b squared, where the c is the longest part of the triangle and also the hypotenuse of the triangle. So that the modulus of this vector r, or same thing as its magnitude, will be the same thing as the root of 4 squared plus 3 squared. 4 squared is 16 plus 3, which is 9. So that the modulus r will become the root of 16 plus 9, that's 25. So that the root of 25 is the same thing as 5. Now from our source, in case you miss our lesson on source, also include a link in the description so that you can have access to our lesson on source. Now the root of 25 is just basic roots, is what? Is 5. So our modulus is 5. Now for the direction, to solve for the direction, if you go back to our Cartesian coordinate here, and to solve back for this direction theta, you see opposite theta I have 4, and adjacent to theta I have 3. Now using SOHCAHTOA, I will also place a link in the description pointing to our lesson on trigonometry where we treated SOHCAHTOA. Now for the angle at theta, you know that tan theta is the same thing as opposite over adjacent. So that tan of theta will be the same thing as 4 over 3. So that tan theta is the same thing as 1.33. So that theta will be the tan inverse of 1.33. You can easily do that with your calculator. Let's use our calculator. From my calculator, the tan inverse of 1.33, tan inverse of 1.33 is the same thing as 53. That means theta, my theta will be equals to 53.061 in degree. You can pause the video to take a look at the second question. Now for the second question, let's solve it together. I have my I, let's call this r once more, so that the modulus of r, we already know that the modulus of r will be the same thing as the square root of minus 2 all squared plus minus 5 all squared, which is equals to the square root of 2, that's 4, plus the square of 2 is 4, the square of minus 5, minus times minus is plus, and the square of 5 is 25. That's the same thing as the square root of 29. Now the square root of 29, if you follow our lesson on solves, is an irrational number. Root of 29 is an irrational number, and because we cannot divide it any further, it's also a prime number. 29 is a prime number, so we'll leave the root of 29 as itself this way. So the square r, the modulus of r is equals to the square root of 29. If you use your calculator, the root of 29, square root of 29, that's the same thing as that's the same thing as 5.3851, and it continues. So we'll approximate it to be the same thing as 5.39 in degrees. Sorry, not in degrees, 5.39. We're given the dimension for the question. Now, for the angle, for the direction, we know that tan theta obviously is equals to minus 5 over minus 2, which is the same thing as 5 over 2. That's equals to 2.5. So if tan theta is equals to 2.5, then theta is equals to the tan inverse of 2.5, which is equals to, with the aid of my calculator, the tan inverse of 2.5 is the same thing as 68. Same thing as 68.198. That's approximately 68.2 in degrees. So it has a magnitude of 5.39 and also an angle of 68.2. Thank you, and see you in our next lesson.